Hello all, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the subject Mathematics 2, and our chapter is first order ordinary differential equation, and today's topic is non-exact differential equation. That means in this method we will learn how to find integrating factor which helps us to make non-exact into exact. Okay, this is part 1. That means each part has we will include two methods to find integrating factors. Okay, so let's start with the first. What is a non-exact differential equation? So if for the differential equation m dx plus n dy is equal to 0, if del m by del y not equal to del n by del x, then we can say that this given differential equation is not exact, non-exact or not exact. Okay, now we understand that what is non-exact differential equation, but what is integrating factor? That means a function after multiplying with this differential equation, that equation become exact, that because of that function. Okay, so suppose we have one function f of xy, and if we multiply this function with given differential equation and this entire equation become exact, then this function is called integrating factor. Okay, that means a function or a factor which help us to make non-exact to exact. This is our integrating factor. So now we have different six method to find integrating factor depending on the question. Okay, if question is in particular form, then we will apply method 1 or method 2 or method 3, 4, 5, 6. So first we'll start with the method number 1. In method number 1, if m dx plus n dy is equal to 0 is not exact, first condition, but it is homogeneous equation. That means homogeneous differential equation. And we have mx plus ny. That means multiply m with x and multiply n with y. It's become mx plus ny. Addition of these two is not equal to 0, then if becomes 1 upon mx plus ny. This is our if. So for that you have to remember that given differential equation is non-exact and this equation is of the form homogeneous. Now you have one question in your mind that if sir this is homogeneous, then can't we solve this differential equation by that homogeneous differential equation method? Yes, you can solve, but we have this different another method is also we have, that by checking this, if it is not exact and it is of the homogeneous form, that homogeneous differential equation, then if is 1 upon m into x plus n into y. Okay, so to understand this method, let's have a look on one example. Here you can see that this is homogeneous. Multiply x in this bracket, so x square xy, so 2 degree 2 degree 2 degree 2 degree, so each and every term has the same degree, so this is homogeneous function. So now you can solve this differential equation by homogeneous differential equation method. That means by putting y by x is equal to v. Okay, that means y is equal to vx and so on. But if I want to solve this by integrating factor, then we have to first simplify this question. So we'll just multiply in bracket and take dx on the right hand side. Now we'll take this entire term on the right hand side. So we have this minus this is equal to 0, equation number 1. Now this become our m and this is our n with this minus sign. So m is equal to xy plus y square, n is equal to minus x square plus xy. Now we know that what to do, that we have to differentiate partially with respect to y of this function m. So we have x and 2y, and differentiate n partially with respect to x, so we have 2x plus y. You can see both are not equal, so del m by del y not equal to del n by del x, therefore given differential equation is not exact. Now it is not exact, but it is homogeneous equation, that is homogeneous differential equation. So what? So we can find mx plus ny. So first we will find mx plus ny. That means multiply m with x and n with y. So we have this two term, and by cancel out this two, we have remaining xy square plus xy square, so 2xy square, which is not equal to 0. So if is equal to 1 upon this value mx plus ny, that means this value. So this is our if. That means this becomes a function which multiply with the given differential equation, and given differential equation become exact. So we will multiply this to the equation number 1. Okay, so we have this and we multiply with this into dx. I just forgot to write down this, and multiply this to n, and dy is equal to 0. So now we simplify, that means multiply this term in the bracket and multiply this term in the bracket. So we have this, after multiply with this, so x cancel, 1y is cancelled, so we have 1 by 2y, and for this y square is cancelled, so we have 1 by 2x. Similar way here. So now this is our new m and new n. If you want to check, then you can check by taking m and n, by taking del m by del y and del n by del x, both will be same. So this become exact, compulsory. Okay, so no need to check. Now if this is exact, then what is the solution? We know that how to find the solution. The solution is integration of this and integration of this is equal to c. But when we integrate this part, we'll put as it is, but consider this y as a constant, treat y as a constant. But here, whenever we integrate with respect to y, as we have already discussed in previous lecture, we have to ignore the term which contain x. That means we have to take term free from x. So we will take only this term, and we will put c or c dash or c1 c2 anything as I told. Now we will integrate with respect to x. So x, multiply this with x, 1 by 2 constant ln x, minus minus plus 1 by 2 ln y, and we will take c dash as a ln c, as I told, because whenever we have ln in the integration, we will put constant as ln. Now by simplifying, taking LCM 2 2 2, so we have 2 ln c, and by simplifying this we have ln c square, and by using logarithm rule, log xy, taking on the left hand side, so we have c square minus log ln c square minus ln xy, so this is minus, so in denominator, by taking anterior on both side, we have e raised to of this term, and taking this term on the right hand side, we have this. This is our final general solution. So after the finding if, and when we multiply if to given non-exact differential equation, new differential equation become exact, and after that we know what is the process. Already we learned in previous lecture. Okay, so this is the one method when given differential equation is not exact but it is homogeneous differential equation, then we can find if as 1 upon mx plus ny. Okay, now second method. So in second method, that m dx plus n dy is not exact, but it is of the form, in a particular form, this. That means given differential equation in this form only. That means function of xy, y dx is outside, function of xy, x dy outside, then we will find if by 1 upon mx minus ny, and we know that mx minus ny should not be 0. So we have, why I'm just taking two methods in this lecture, because just we have to remember, if given differential equation is not exact and it is homogeneous, then we have mx plus ny, 1 upon mx plus ny is if, and not exact but in this form, then 1 upon mx minus ny. So what is the difference? Plus and minus. If homogeneous, then plus, and if in this form, then minus. Okay, so what is the meaning of in this form? That means if I said function of x, that means we can write log x square, anything, sin x square, anything. But here ask function of xy, that means function of xy, that means you have to write xy together like this xy, or you can write x square y square plus x cube y cube, but you cannot write x square y. But if we have this x square y and y, then we can take y outside, so we have x square plus 1, even though this is not function of xy. We need function of xy. Here there is no comma, x into y, this is x into y, just that you have to keep in your mind. Okay, so x into y. This is x into y whole square, x into y whole cube. But here it is not possible x into y whole square. That's why it is not function of xy. Okay, so what is the function of xy? Now that you have to remember. Okay, so if we have this, then we can find if by 1 upon mx minus ny. So to understand this method better, we have example this. So first we will start with the m dx and divide. So what is m? This entire is our m and this entire is our n. So first we have to check if it is not exact or exact. If it is exact, then no need to find this if. Okay. If it is exact, then go with the flow of the previous lecture. But if it is not exact, in that case we have to find if. Okay. So this is our m. We'll multiply y in this bracket. So m is equal to this xy square 2x square y cube, and if you multiply x in this bracket, x square y and x cube y square. Now differentiate this partially with respect to y, differentiate n partially with respect to x. We know the differentiation, so I'm not going to put more time, more effort, because you should know the partial derivative already studied in first semester. And now you can check these both are not equal. That means given differential equation is not exact. Now it is not exact, but now we have to check it is in the form of this or homogeneous. It is not homogeneous. Why? Sir, degree 2, degree 4 different, and if we multiply y inside this, so we have degree 3, degree 5, here degree 3, degree 5, not same. So it's not homogeneous. So now we'll think about the this form function of xy. So here function of xy, you can see xy whole square, yes, and y dx is outside, y dx in group together, x dy in group together, and this is a function of xy. Okay, so this is our not exact differential equation, and but it is of the form this. So we'll find mx minus ny. That means we multiply this m with x and n with y, and we subtract both them. So by opening the bracket, we can cancel out this term. So we have 3 x cube y cube, which is not equal to 0. So if will be 1 upon mx minus ny. That means 1 upon 3 x cube y cube. Now after finding if, we know that we have to multiply this if with equation number 1, which is this. Okay, so we multiply equation 1 by if. So 1 upon 3 x cube y cube with this bracket, and 1 upon 3 x cube y cube with this bracket. Okay, and by simplifying this, we'll multiply this with this two term. So remaining term are this, and now this become compulsory exact. If you have doubt, then you can check by taking this m and new n, differentiate partially with respect to y, differentiate partially with respect to x, you will get the correct same answer, equal. Okay, but no need to check if our method, our process is correct. Now, if this is the exact, then what is the solution? So the solution is integration of this by consider or by treating y as a constant, but will not remove any term. Okay, but whenever we'll take this, we'll take term free from x. That means this term will not included, only this term is included. So we have this. Now integrating with respect to x. So 1 upon 3y is constant and 1 upon x square. Integration of 1 upon x square is what? So integration of 1 upon x square, that means integration of x is to minus 2. That means x is to minus 1 upon minus 1. 1 power plus that power is denominator. So we can write minus 1 by x. So we have this minus 1 by x. And 2 by 3 as it is, 1 by x is log x, plus minus minus 1 by 3 as it is log y. Similar way, you can simplify this step, or you can left with this answer also. This is our general solution. If you want to simplify this step further, so take 3 LCM, so multiply here 3c, and by taking 2 on the power, 1 on the power, and by simplifying by taking log. Simple. Okay, otherwise you no need to simplify this term. This is also considered as a correct answer. Okay, no need to simplify more step. Okay, so these are the two methods. Now we have these examples. Okay, which are the combination of two method, that means method 1 method 2. If given, that means m dx plus n dy is equal to 0 is not exact, okay, not exact, but it is homogeneous, then if is 1 upon mx plus ny. And if it is particular form, now you should remember that form is function of xy into y dx, opposite y dx, plus function of xy and x dy is equal to 0. If this form, then if is 1 upon mx minus ny. So you have to just remember homogeneous, then plus, and particular form, then mx minus ny. So now you can identify this is homogeneous, 3 degree, 3 degree, 3 degree. But before that, you have to check by taking m and by taking n. And if it is directly exact, then no need to use this if. Otherwise, if will be 1 only. Okay. Now this is also homogeneous, I must say, because 3 degree, 3 degree, 3 degree, and 3 degree. And these three are of method 2. That means function of xy, as I told, y dx, function of xy, x dy, function of xy, y dx, function of xy, x dy. X dy and y dx must be there out of this bracket. Function of xy, function of xy. Okay, so these are the example based on these two method, okay, that you have to solve by yourself. Try to solve. If you have any query, then you can contact me, or we will discuss in Zoom lecture. Okay, so thank you for watching this video, and keep practicing. This will help in examination and will help in next method also, because non-exact has 6 methods, so you have to remember each and every method. Okay, so thank you for watching today's lecture. Thank you.